Good afternoon and welcome everyone to today's webinar, Stamping EV Battery Parts for the Automotive Industry. The webinar today is presented by SIMPAC America and hosted by Metal Forming Magazine. I'm Brad Kuvan, I'm the editorial director at Metal Forming at the Precision Metal Forming Association, and I'm pleased to serve as your moderator for today's session. Before we get started, just a few notes about today's GoToMeeting session. This meeting is being recorded for archiving, and a recorded event will be posted to our website within the next couple of days. We'll let you know via email when that recorded webinar is available for you to view online. Also, all participants in this meeting are in listen-only mode. The speaker and other listeners will not be able to hear any audio from your site during the program. However, you do have the ability to communicate with us throughout the program by submitting your questions and comments using the question box, which is located down on the right-hand control panel on your GoToMeeting screen. So you simply type your question to an organizer as selected from the drop-down menu. You'll use that same question panel to ask questions of our speaker at the end of the presentation. So let's go ahead and begin today's webinar. Our speaker this afternoon is Stefan Robertson. Stefan is the General Manager and Vice President of Sales and Operations at SIMPAC America. He's got more than 30 years of experience in the metal forming industry, and with his highest priorities being customer satisfaction and brand integrity. Today, Stefan's going to talk to us about the growing importance of the EV market for metal formers and offer some best practices for stamping EV battery parts. So without further ado, I'll turn the presentation over to Stefan.
Well, thank you very much, Brad. And now you make me feel real old by saying that I've got over 30 years of experience. So anyway, my name is Stefan Robertson. I'm the General Manager of and VP of Sales and Operations for SIMPAC North America. And I'm here today to, as Brad stated, to give a presentation on the stamping of EV battery parts for the automotive industry. But before I do, I'd just like to give a quick shout out to both Brad and Marlene from Metal Forming Magazine for not only introducing me, but for also putting all the time and effort together and setting this all up. I'd also like to give a thank you to my inside sales and marketing manager, Jamie Bartholomew, for helping me with all of the research that went into this presentation, and without whom's help, this would not have been possible. With that said, I think we'll start off with why should metal formers know best practices for stamping of EV battery parts? Well, if you look at this rather basic graph and curve, you can see that as the batteries get a longer charge, and we will definitely be discussing this in some future slides, and as EV vehicles start to become more cost-friendly, you will get a natural increase in demand for EV vehicles. This will not only be driven by certain cost triggers such as gas pricing and, or for that matter, vehicle maintenance, but also by the force of the younger generation's interest in cleaner energy usage as well as having a smaller carbon footprint. First though, before we go into detail about not only the global but also North American EV market, I personally believe it's important to see what has been happening with the global light vehicle market in general. In this slide, we take a look at the global and the North American light vehicle sales and production. On the left side, you can see how the global light vehicle market has increased and then obviously for this year, sharply decreased due to COVID-19. And also with what they're anticipating, a slow, gradual incline moving forward. On the right side, we also show the North American light vehicle market production and how this is pretty much mirroring the global market. Now, of course, with North America, we show that we're looking at approximately 2025 to 2026 before we get back to the approximate production levels that we showed in 2019 before COVID. Now, of course, before we move forward, you might be asking yourself, why is this important to see? As, hey, it's pretty obvious that there's been a decline due to COVID-19. I mean, I think pretty much all of us were sitting at home for 2 to 3 months, and most of the OEMs were shut down, and a lot of the tiers were shut down as well. Please be patient with me because obviously the reason for this is going to become a little more and more prevalent as we go through these slides and through this presentation. Now with this slide, things start to get a little more interesting. As you can see on the graph on the right, we show the global EV sales growth from 2011 through 2023. Now, obviously, as we move forward in the years from today, these are anticipated growth volumes. But one of the things that we can show here with pretty good certainty is when we look from 2019 to 2020, we show an approximate 22% increase in demand for EV vehicles. And we continue to see an anticipated growth moving forward all the way at least through 2026. When you compare that to the light vehicle sales that we showed in the slide before, where there was a huge decrease in demand, this makes things start to become a little more interesting as we see the EV market is growing and not shrinking as opposed to what we've seen with the regular light vehicle market. On top of that, we're looking at an anticipated vehicle growth of up to 26 million EV vehicles by 2026. And again, part of this is due to the new battery technologies that are coming out, and also as the price points of vehicles start going down to match that of traditional gas-powered vehicles, you're going to see that increase as well. But before we go into our next slides, one can obviously argue that this is just a very small niche segment. I mean, if you look at this right now in 2023, we're only looking at maybe 4.5 million vehicles for North America. It really isn't, well, not North America, for worldwide production. It really isn't that much in the grand scheme of things. But with the future slides that we're going to show, hope to be able to change your mind on that. This slide here shows the actual planned global EV sales production powertrain technology, not only from historical data up through 2019, but what also the anticipated growth is going to be all the way through 2032. There's a lot of information on the slide to go through, so please bear with me a little bit here as we start to digest this. The main purpose of this slide is to drive home how the EV market has expanded and how it is expected to expand over the next 10 to 15 years. The graph on the left shows the global EV stock and how it has increased in the millions for all vehicle types from 2010 through 2019. Obviously, we can see that China is leading the way with their EV expansion, closely followed by Europe and North America. On the right side, we see what the anticipated global powertrain technology will be by 2032, and the forecasts on how the breakdowns are. One of the things that's important to note is that we're looking at approximately a 27% market share for not only Europe, but also Greater China by 2032. Unfortunately, we see the U.S. is only forecasted at 12% by this time, but we also believe, based on some of the slides we're going to show here moving forward with some actual data, that this number has a potential of being closer to 20 to 25%. We also believe that while we generally agree with IHS in regards to the percentages that they're showing, except obviously for North America, we believe that these numbers are actually going to be reached 2 to 3 years before the 2032 discussion point. Now, throughout my years in sales, and Brad was so kind to state that I've been in this business for at least 30 years, I've seen many euphoric slides. And I've seen many different things where people are talking about different automotive technologies. And to be quite honest, pie charts and graphs are all nice and everything, but one of the things that a lot of times we don't see is facts and figures. Next slide, I hope to bring a little more context to what we've seen so far. In this slide, we show you where the previous slides were getting some of their numbers. This has been done through research by SIMPAC Inc. and also my inside sales and marketing manager, Jamie Bartholomew. And you can now start to get a clear picture of who is driving this change / increase in the EV market. And again, I just want to give a shout out to her because obviously her hard work and patience, definitely with me, has helped put all of this together and made this hopefully a success not only for SIMPAC, but for everybody else that's listening. Please note, when you look at the slide, this is quite honestly only a snapshot of what is planned, and these numbers will definitely change as more announcements are made over the coming months and years. I mean, if you looked on the internet this morning, there was an announcement made by GM and another one by NIO. Those aren't even in this presentation. For instance, when you look at this graph right here, just like what we just mentioned about NIO, they're not on this graph, nor is Fisker, Rivian, or Energica. But some of the major targets that do stand out on this slide that are important to note is, first of all, Volkswagen, where they have publicly announced that they're planning on having 300 EV models launched by 2030. Tesla, though maybe this might be a little euphoric, has announced that they plan on producing 3.5 million models this year. GM, which we're going to discuss a little bit more in future slides, has stated that they are going to invest $20 billion in EV and AV production between 2020 and 2025, with a sales target by 2030 of 5 million EV vehicles. Toyota, which unfortunately we weren't able to get as much information as we would have liked to by the time of this presentation, also has shown a sales target by 2030 of 5.5 million vehicles. Please note, as you can see from these facts and figures and these numbers and publications that you can easily find on the internet or through the company's websites, this once again shows why we believe the 2032 percentages shown on the chart in the previous page might actually be met by 2028, maybe 2030. Now that you better understand a little bit about the EV market and that is showing a tremendous value and expansion, we'd like to cover which EV battery parts are metal formed and which presses SIMPAC believes are ideal for stamping these parts. Before we go on to that though, I'd like to show you this graph that once again shows you the increase in demand for batteries for EV vehicles in general moving forward. As you can see, this graph exemplifies the continuous demand for lithium-ion batteries, which is forecasted to further dramatically increase through 2030 and beyond. As one can see from this graph, the largest increases are shown in passenger and commercial EV markets. It is important to note, however, that due to continuous technological advances in the battery market, and we will get into that in the next couple slides, this graph will most likely dramatically change in the coming years. Please also note, this currently does not take into consideration any new gen battery types that certain OEMs have yet to announce, and we'll discuss that also in future slides. With that said, let's now get into the standard EV battery composition. It is important to understand that batteries are currently mounted in the form of modules and packs for safety and efficiency, though there is the strong potential for this changing over time with new advancements in technology. For this presentation, though, we're going to focus on cells, which are basic units of lithium-ion batteries, modules, battery assemblies in frame, and packs, which are the final forms of the battery system to be mounted to the EVs. Now, before we go into too much detail, we just wanted to show you some examples of OEM EV battery compositions. Please note that depending on the OEM, EV battery packs will differ in shape and mounting position, as well as depending on vehicle type, size, and definitely driving performance. We show some of the examples here, and these are by no way, shape, or form the only examples that are out there. But for this presentation, we just decided to pick 5 different models to show you. One of them is the BMW i3, which shows cells, modules, and packs. The Tesla Model S, an uppercase cover example for the VW e-Up, a lowercase tray example for the Nissan Leaf, and a cell module for the GM Volt. Now on this slide, we start to break things out into a little more detail and show some of the items that are currently being metal formed. Please note, and I am definitely going to sound like a broken record at some point in time during this presentation, there is a high probability that some of these items will change over time, especially with the advancements in technology and material composition. For this presentation, however, let's stick with what we've got right here. First, we've got cells, which you can find as an example in cylindrical, quadratic, or upper, lower pouch cases. Modules, which come in the form of plates, cooling pins, bus bars, and monoframes. And packs, which come in the different sizes and shapes of cases and cooling plates. It is important to note that these pictures are only examples and there are many different variations out there in the market. We're just using these as an example for this presentation. Okay, so I'm pretty sure that by now you're starting to wonder if I was ever going to start talking about SIMPAC presses. Well, why don't we start doing that? And of course, in this slide and over the next two slides, we're going to talk to you about the general types of presses SIMPAC recommends in order to form specific individual battery parts. In this slide, we depict individual cell parts from the previous slide and talk about some of the general presses that can be used to form these parts. In general, cell parts require only small to medium-sized presses ranging from 40 to 1,100 tons. Now, and again, I'm going to keep on repeating myself here, this obviously depends on the part, the size, and the configuration of what is being formed. In this slide, we show the press types of the CS, MC, MCL, and NCD series. On this next slide, we show the SIMPAC recommended stamping presses for module parts. This slide depicts individual module parts from slide 10 and talks about some of the general presses that can be used to form these parts. In general, module parts also really only require small to medium-sized presses ranging from 40 to 1,100 tons. And once again, this also depends, obviously, on the part size, the part itself, and the configuration of what is being formed. And in this slide right here, we highlight the MC series and the ECS series. On this slide, on this final slide here for stamping presses, we recommend specific stamping presses for cases and plates. These parts require medium to large size presses and or press lines ranging from 300 to 2,500 US tons. And once again, depends on the part, the size, and the configuration. Now, if you're like me and you've looked at this slide and the last two slides, you're probably thinking, why hasn't SIMPAC mentioned anything about servo press technology? Well, we do have a lot of different servo presses, ranging either from the SV2P, 4P, MX, or SX series presses. And I'll make sure to go into those in a little more detail during our question and answer period after this presentation. One thing also to note is that all registrants, whether you're our competition or a potential customer, will receive a copy of this presentation with hyperlinks to the technical specifications of the recommended SIMPAC presses and press lines. As you can see from each of the pictures, at the bottom of each of the pictures it shows technical specification. You click on that, it'll take you directly to the full detailed explanation and specifications of that specific press. If, however, that doesn't work or you require any additional information, please feel free to contact either myself or anybody here in SIMPAC's office in Troy, Michigan, and we'd be more than happy to help you. Now that we have a better understanding of why metal formers should care about stamping best practices for EVs, what specific battery parts are metal formed, and what general press types SIMPAC believes are ideal for forming EV battery parts. We would now like to cover who the main battery suppliers are and who are the key EV players post-COVID-19. In this slide, we show some of the key global EV production players post-COVID-19. Now, here we see what the anticipated global market share for some of the main players in the EV market are anticipated to be by 2027. Please note that as some of these companies will most likely push some of their plans forward or backwards post-COVID-19, the market share percentages will most likely change to some extent. For instance, we have personal knowledge that more than one major OEM is currently in the planning stages of canceling a planned gasoline-powered vehicle launch and replacing it with an EV architecture. One of those companies is mentioned on this slide, one of the companies is not. Also, it is important to note that there are other key OEM players not included in this EV forecast chart, and those are, and we'd like to mention, for instance, BMW, Volvo, NIO, Rivian, Fisker, Toyota, and Energica, to name a few. Now, the reason why we have this slide, and to a greater or lesser extent the next one, is that I keep on hearing several things over and over again in the market as to why EV vehicles will never take off, and one of these is obviously the battery technology / the charge is too short and the charging time is too long, yada, yada, yada. Well, let's talk about that. This slide discusses 4 major announcements that have recently been made in regards to EV batteries. And I apologize in advance, I'm definitely not talking about all the announcements that have been made, but that is obviously due to the time limitations for this presentation as a whole. With that said, some of the EV battery announcements are General Motors. General Motors has announced that they're reducing their cobalt content for all of their future EV lineups by over 70%. Also, and this was just put out in the internet today, GM has broken ground in May of this year on a $2.3 billion joint venture with LG Chemical in Lordstown, Ohio. And this is part of the $20 billion investment plan that we discussed on page 6 of this presentation. They have also announced that post-COVID-19, all of their Ultium platform vehicle programs are on schedule and that 20 EV models will be launching by 2023. Tesla. Elon Musk is planning a public announcement / battery day on September 15th. Again, this could change pending whatever happens with COVID-19, but to be quite honest, knowing Elon Musk, nothing's going to stop him. From everything we hear, he's planning on sharing new Tesla battery advances, as well as we suspect that he's going to be discussing CATL's million-mile battery that will be used in the Model S and Model X upgrades. Now, we're going to specifically talk about CATL in a second as well, but it's important to note that this battery is very cost efficient and has a 400 to 500 mile range per single charge. This now puts battery technology on par with standard gasoline vehicles. One other thing that's also important to note is Tesla has their own in-house battery production at their current Gigafactory in Nevada and are planning have just recently announced their plans for a new factory and are breaking ground in Texas for such. They've also been discussing anticipated gigafactories worldwide, not only in Asia, but also in the UK and in Europe. Kia Motors, Hyundai, and LG Chemical launched a battery challenge in June of this year. And this was to inspire collaborations and to fund startup companies to bring EV and EV battery technology into production worldwide. These applications are actually due, I think, by tomorrow, and they will be announcing the winners shortly thereafter, and the collaborations are to begin in November of this year. CATL. Now, we just discussed this a second ago under Tesla, but it's also very important to note that they have announced a 1,000,000-mile battery in June of this year. It is cobalt-free and lasts for 1.2 million miles over a 16-year lifespan, and is currently available for purchase. With that said, I want to show you a couple of the major battery suppliers and the OEMs that are using them. Now, please note this is honestly only for example purposes. We're obviously not showing all of the EV battery manufacturers. We're just trying to show some of them. For instance, one battery manufacturer that we have not noted in this on this slide is Northvolt, and they work with Volkswagen. Please also note that there are several other OEMs that are major OEMs that are making their own batteries, like Tesla, as discussed in the previous slide, or have special collaborations with other battery suppliers. Now that we have a better understanding of who the key players are in the EV market and the main battery suppliers, we can now cover where global and domestic EV infrastructure changes will likely occur in the future. In these next two slides, I'd like to talk about another important potential roadblock to mass acceptance of EV vehicles, and that is the charging infrastructure and where we see this going. When you look at the global EV infrastructure as of 2019, you see that public chargers of all types have increased by 60%. And this is based only on an EV stock of approximately 7.2 million vehicles. Currently, we show that China holds approximately 82% of the world's public fast chargers, with Europe holding 6% of the world's public fast chargers. What's interesting to note is the United States, with more garages and single-family homes, has 24% of the global private chargers, but currently only has 12% of the global EV stock. Most of these chargers are, however, located on the West Coast and being driven by the more eco-conscious younger generation. And if you're like myself, whenever you're driving around here in the Midwest, at least I'm from the Midwest, can't say that about everybody, but when I'm driving around Michigan, Ohio, or Indiana, I do see EV charging stations, but not very many of them. And that's just being honest. I see them at private companies. I see them at friends, some of my friends' houses. And of course, when I fly out to the West Coast, I see them all over the place. Once we start having a more mass acceptance of this, we are going to start seeing a dramatic increase in shift away from gasoline-powered vehicles and towards electric vehicles. I'm not saying the gasoline engine is going to go away. It most certainly isn't. But the market share for EV vehicles is going to dramatically increase based on the cost and the charging potential in the future. One of the things we see that by 2030, we expect the U.S. to match and or exceed Europe's increasing charger availability rate and to increase their percentage of the world's private chargers, just as I stated before. One interesting point is that post-COVID-19, many markets are getting government stimulus packages in order to help push the trend towards EV. For instance, France and Germany have announced incentivization plans for the EV market recovery, and this is helping them propel the EV market share, as we've shown on slide 5, for Europe to 27% by 2032. Unfortunately, the U.S. has currently not done this. That's why most likely the slide only shows a 12% market share. However, we strongly believe that as the younger generation pushes for change, and make no doubt about it, the younger generation will push this. And with the U.S. government incentivization of this market, this share has a massive potential to increase into the 20% range by 2032. Now on this slide here, we not only are showing where we currently are in regards to chargers for the U.S., but also where some of the true potential customer cost savings are going to EV. Currently, as we stated in the slide previously, public U.S. EV infrastructure has over 24,000 public charging stations with over 82,000 public charging outlets. Once again, as I said in the previous slide, most of this is on the West Coast. And this is obviously going to need to change over the next 3 to 5 years as more and more vehicles come to the market, as well as the need to increase the private charging stations. Now with the announcement of GM and with other major OEMs forcing this change, we believe that this is going to happen, and it's probably going to happen a lot faster than either you or I think. On the pie chart that we show here on the right, we show the national average of prices as of April 2020. Now, to be quite honest, we all know gasoline prices jump up and down like a pogo stick depending on what oil companies are deciding to do or who's fighting who in the world on a daily basis. But no matter how you look at it, gasoline prices range anywhere from, let's say, $2 all the way up to worst case scenario, $4 per gallon. But when you look at what a per kilowatt hour costs for EV batteries, you realize the huge potential in cost savings for the consumer in moving more and more towards EV markets, especially when you start talking about an EV charge of a 400 to 500 mile range, and you also start discussing that EV vehicles are starting to become more and more in line with the general gasoline-powered vehicles in price. One of the other things that we see as EVs are becoming more affordable for the mass market, we're also seeing that Envision Solar, Envoy, LACI, and Pacomia Beautiful are launching solar-powered EV charging stations for on-demand shared vehicles, especially for the disadvantaged communities. It should also be noted, as per our previous slides, GM is partnering with EVgo, ChargePoint, and Greenlots to launch the U.S.'s largest EV charging infrastructure of 31,000 plus charging stations. Obviously, due to COVID-19, this timing might be a little bit TBD, but this is just underlying the importance that everybody is taking into bringing the EV charging infrastructure online here in North America, and this isn't something that's going away. It will happen. Now that we've covered the who, what, when, where, and why for stamping EV battery parts, and you can now more clearly see that not only the huge potential in this technology, but also how this is going to affect the stamping and forming world moving forward into the future. It's now time to learn a little bit more about how capital equipment suppliers such as SIMPAC or our competition can support metal formers in becoming more profitable when producing for this market. Now, capital equipment suppliers such as SIMPAC can and should be used as an informational resource when deciding on new equipment purchases. In this slide, we show some of the requirements and/or tips that can be used when deciding on what specific type of equipment can be used for the cutting and forming of EV parts. Now, obviously, we at SIMPAC are very happy to provide our recommended press requirements and tips to you based on what you're trying to form. But if SIMPAC is not your preferred press manufacturer, then please confirm with your partner of choice, as all press manufacturers will have different specifications or potentially different approaches when it comes to equipment types and specifications, whether it be mechanical or servo. Finally, moving forward, capital equipment suppliers such as SIMPAC need to provide better technical expertise and serviceability of their customers' equipment as the EV market continues to expand, especially since the need for new equipment will be needed for many of the EV stamping applications in the future. With that said, we have 5 or 6 areas that we'd like to highlight in regards to this. First is the price and performance ratio. We at SIMPAC believe it is important to look for suppliers that can offer a strong balance of price and performance. At SIMPAC, we have combined German engineering with Korean manufacturing to achieve this efficiency. Next, and also on the third point as well, we talk about equipment serviceability, spare parts inventory, and accessibility. As technologies evolve, it has been and will continue to be important for press manufacturers to continue to assist their customers in holding certain spare parts inventories locally, as well as improve the serviceability of the equipment they provide. SIMPAC, for instance, has done this by partnering with D&S out of Hastings, Michigan, and are now using a portion of their new 12,000 square foot warehouse to store certain critical long lead items. It is important to note that D&S was planning on having an open house to showcase this new facility, and unfortunately we then had COVID happen, so this has been delayed. Well, hopefully in the fall, but most likely based on what's going on with COVID, this open house might not happen until the spring of next year. Also, SIMPAC is very happy to announce that they've hired a new electrical and controls engineer with over 20 plus years of experience, and we're in the process of hiring another one in the fall of this year. This leads us directly into immediate accessibility, as suppliers such as SIMPAC must provide immediate accessibility either in support centers or service organizations, as these go hand in hand with our customers. We've known from the past, and we realize for the future, that as SIMPAC, we need to become stronger and stronger for our customers. And that's why we've not only partnered with D&S to store certain long lead items, but we've also started hiring several service technicians so that we have in-country service support and not have to always rely on bringing somebody from Korea. Next, we talk about quick delivery. I personally believe, and I think also many people at SIMPAC believe as well, it is important to work with capital equipment suppliers that can control the production process from start to finish, so that expedited deliveries can be achieved when needed. As we all know, an OEM doesn't necessarily go by what your schedule might be. They're not going to tell you exactly 12 or 14 or 16 or 18 months in advance, yep, this is what we need. Sometimes they only give you 10, 11, and if you're lucky, 12 months to buy that 1,000, 2,000, or 3,000 ton press. And you need to make sure you work with a capital equipment supplier that has complete control of the production process so that they can achieve those delivery times for you. With that said, SIMPAC has extensive in-house production capabilities such as a massive plate inventory and world-class casting gear and fab shops. Now, people can argue this back and forth, but if you were to look at my resume or my profile on LinkedIn, you will note that I have worked at several other capital equipment manufacturers, and I can emphatically tell you that I have been at their manufacturing facilities during my years, and I can also tell you that the casting gear and fab shop at SIMPAC is definitely world-class. Fifth is obviously turnkey solutions. And this is very important to either find a press manufacturer that can either provide a complete in-house turnkey solution or one that has special relationships with automation companies that know the press manufacturer's infrastructure inside and out. SIMPAC is obviously proud to be able to state that they are able to do this because they have currently 3 different major automation suppliers in Asia that they have been working with for many, many years. We're also currently working with to analyze and signal out several American automation suppliers as well, so we can offer this type of solution to our customers. We believe that our customer comes first, and this is always based on what the customer's wants and needs are, not what we're telling them what they should be. Finally, it's important to form a strategic partnership with your suppliers. Press manufacturers like SIMPAC with 100% control of the production process from start to finish, help to enable metal formers to save on time and costs while remaining competitive. With that said, if you would like to have any additional information on what capital equipment suppliers can do to support metal formers, there is a web link that you can press on the bottom left here that'll go to Metal Forming Magazine's webpage for the 6 ways capital equipment suppliers can support metal formers that we have done as well. Before we go into questions that have racked up during this presentation, I would once again like to thank everybody at Metal Forming Magazine, all of the people that have patiently listened to me drone on, and my inside sales and marketing manager for being patient with me, not only today, but in the weeks before this presentation. And I hope that this will help you for the future and make everyone more successful. Thank you very much.
Thank you, Stefan. Really well-rounded presentations, and thank you for your efforts as well for putting all that information together for us. We are open for questions. We got about 15 to 20 minutes, so you can use that question panel down on the control panel to type your question in to an organizer. So first question, you kind of touched on servo, but didn't spend a lot of time talking about traditional mechanical press versus servo for the battery component specifically. Talk a little bit about where you see servo and where maybe you don't see servo technology applying to battery components.
Well, thank you very much, and whoever asked that question, I appreciate that, though I guess I kind of guided that question in the first place. So I just want to say that, obviously SIMPAC has a wide range of servo press technology that we can offer. Whether you're talking about the SV generation servos or the MX or SX servo generations. Approximately every year, when you look at the sales volume and on individual press volumes, we're making approximately 25 to 35% all of our presses as servo presses or press lines. And now with that being said, I think it's important to look at several factors when you look forward going to a servo press or a mechanical press, especially when you're looking at EV parts. First, I think you really have to look at the price of a servo press versus a mechanical press. You also have to compare what the volume of the parts are that you're going to be stamping, and most importantly, the complexity of the part. I mean, don't get me wrong, servo presses are pretty damn cool, and they've got a lot of many unique attributes that are hugely beneficial, especially in the forming process, while also, as we all know, having the potential of increasing the part throughput. But with that said, and I'm sure there's a couple financial people sitting out there in this presentation, or at least I hope there are, servo press can range anywhere from 25 to 45% more in cost than that of a standard mechanical press. Now, my competition can also argue, oh, it's only 10%, or some people can argue it's 50%. Not arguing over semantics here, because it all depends on the part, the size, and the complexity of what you're looking at. But you also have to look at what the different operations are you're looking at, and it's not just the press that you have to be concerned with. It's all the peripheries around the press. For instance, if I have a mechanical press that ranges 15 to 20 strokes a minute, and I have an existing die that is running that, and then I put it in the servo press, same bed size, maybe a little bit more tonnage, but all of a sudden it can go 40 to 50 strokes a minute, and that VP of operations, that VP of finance says, well, you got this press, so now run it at 40 to 50 strokes. First thing that's going to happen is you're going to blow apart your die. That's even if you can get the material through the press fast enough to do that, because you got your automation, you got your frontal line, you got your end of line, you got your feed line, you got your decoiler, you got your feeder, and you got your transfer that you have to worry about. So I'm not trying to go doom and gloom about servo. I think that for existing products and existing parts that you're looking at, that you're doing right now, in certain instances, servo might be more beneficial for you. But if you're looking at new parts that you're talking about for the EV batteries or for EV technology, and you're going to buy an entire new system, and the OEMs are going to pay you for those dies that you're definitely going to have to purchase, then yes, servo technology in certain instances, definitely the way to go.
Okay. Okay, good. Thank you. So kind of piggybacking on that then, I think one of the informative slides that you showed emphasized some of the technology requirements of presses in terms of parallelism and accuracy and so forth. So to talk a little bit more about why the newer technology is required to stamp, cut, and form battery components versus maybe older presses that some of our listeners may have in their press rooms.
Okay, well, to be quite honest, I mean, the simple answer is that a lot of your existing stamping equipment will be able to cut and or form EV battery parts. But as the material compositions change and as the tolerance requirements get more and more, get tighter and tighter, you're going to find those older generation presses and the automation that you've been using with those presses are no longer going to be, in certain instances, viable to make these EV parts. That's why we've been talking about, and one of the things that I discussed as well, is as you start getting new programs, you start looking for either the newer generation mechanical presses, or if you can afford the servo press technology and it makes business sense based on the parts that you're making, then it's definitely one of the things to look at. One of the other things that we've noticed is that where you were having maybe one specific type of part that you were stamping off of maybe a 300 to 400 ton press in the past, all of a sudden as you're getting new technologies out there and it's requiring new higher strength materials, you're noticing that 300 or 400 ton press all of a sudden becomes a 5, 6, or maybe even 800 ton press that you need. Now, if you try and run those parts through a lower tonnage press, A, you're probably not going to be able to form them, or B, if you force it through, the shock that you're going to get from the cutting operation itself is going to reverberate through the press. It usually goes right into the crown. And then guess what? You're going to be forced to get a new press anyway because you're going to crack it.
Okay, good. What can you share based on your experience regarding the supply chain evolving? A lot of stampers are providing parts to tier ones, for example. Is the path to the customer going to change where maybe you're going to go direct to the OEM with battery parts, or maybe do you even see maybe the battery companies themselves getting involved in stamping components? Kind of how do you see the supply chain evolving for batteries?
Well, one of the things I've seen is that you're seeing OEMs, let's just talk about traditional vehicles for a second. You're seeing OEMs are starting to push more and more of their stamping operations off onto the tier supply base. In certain instances for, let's say, A-class parts or skin panel parts, the OEMs are still trying to do that themselves. When you look at EV battery parts, a lot of these companies that are coming out have expertise in making batteries. They have expertise in the technology, but they don't necessarily have the expertise in the stamping and forming of such. I personally believe, and again, I could be completely wrong, I'm just one person, but I personally believe that there is going to be a larger and larger need for stampers in the future on the small to medium-sized press range. And I'm talking about anywhere from, yes, I mentioned 40 tons, but I believe anywhere from let's say 100 tons up to about 1,250 tons. I see that's going to be a specialized niche market moving forward. And as these battery companies start becoming more and more prevalent and needing more and more of these batteries, that portion of the market is definitely going to expand.
Great. Okay, I hope that answers the question that was asked. Again, we've got a little bit more time with Stefan if anybody else has more questions. Stefan, where do you see fuel cell technology coming into play, in the marketplace?
Such as how do you mean? I guess, or...
Well, the question specifically is, how do you see fuel cell technology fulfilling infrastructure requirements for battery electric vehicles?
Okay, well, if you look at fuel cell technology, I see that specific OEMs such as Tesla and GM are really pushing that technology, especially with trying to form new alliances and also spurring new technologies moving forward. As we stated before in the presentation, we talked a lot about lithium-ion batteries. I honestly believe that within about 3 to 5 years, we're going to talk about a complete different type of battery generation. What that is, I do not know. I'm not that smart. I honestly believe that people like people from General Motors or Elon Musk from Tesla probably know a world more than I do on this stuff. Also, LG is probably working with and developing all sorts of new technologies on a daily basis. This is going to definitely evolve dramatically over the next years.
Very good. Okay. Turnkey solutions. Stampers, it seems like more and more want turnkey solutions, but why do you see those as more important, maybe in the EV market specifically?
Well, one of the things that I've seen in the past, and I think that it's not just the EV market, it's all of the stamping market as a whole, but obviously we're here to talk about the EV market, is that you're gonna at some point in time gonna need to buy new equipment. Whether it's because of the tonnage requirements, or it's because of the tolerance requirements, or it's because of the technological advancements that are out there. When you buy that new equipment, what I've seen in the past a lot of times, and these are mistakes I also personally made, and I've seen other companies make, is they'll buy a press from one company, they'll buy a piece of buy a decoiler from another, a feeder from another, and a transfer from a next person, and a coil cart or whatever from another company. And then you get a mishmash of everything trying to talk with each other. Or you all of a sudden get a feed line that isn't going to match up with what the press speeds are. So the press obviously isn't being utilized the way it should be. By going to a turnkey solution, either from SIMPAC, by using one of our special suppliers that we've worked with, or potentially with one of my competition that does full turnkey systems in-house, what you do is you're able to then have everything talk with each other and have a lot more seamless operation moving forward. I think this is going to be very important because people are not going to have time to waste on having people either point fingers at each other or have things not work.
Right. So when it comes to systems, the system approach, where do you see specifically with transfer technology? Is there a direction of that technology development specific to handling the EV battery components?
Well, I think, to be quite honest, I come from a stamping press background. So I know of multiple transfer companies that are probably better versed in answering that than myself. I personally know of 2 companies that are very highly reputable. One of them is Linear, and the other one is HMS. Both of those companies are very well versed in obviously as transfer companies in how the technologies are moving forward. And sorry to punt on that question, but to be quite honest, I would defer to one of those 2 companies.
Okay, fair enough. So from the press manufacturer perspective, then the question is, where do you see the press technology differing if an OEM chooses to use for battery protection using high-strength aluminum versus a high-strength steel? What's the difference in press technology that you would recommend in those 2 applications?
In both of those applications, I mean, now again, there's different thought processes that I've seen in the market. And as a press supplier, we try and work with the customer to help them make an informed decision. We don't try and force them either into a mechanical press technology or a servo press technology. If you're looking for, I have seen customers that decide that they want to go for higher and higher press tonnages. That's why you see very large transfer presses, either in eccentric or link drive, at approximately 3,000 tons. I've also seen other customers that prefer the servo technology, and those have especially strong feature benefits when you're looking at that as well. Both of them work very well. It all depends on the knowledge that the customer has on those technologies and what kind of people that they have working in their facilities. It makes absolutely no sense to buy the absolute latest and greatest technology in the world if you don't have the proper manpower to run it. You can't expect a press supplier, whether it's one of the big two or SIMPAC, to be able to help and support you 24/7 on working on a servo press or servo press line if you do not have people in-house that also understand that technology and are willing to try and learn how to use it.
Fair enough. So following on that, then, do you see hot forming or warm forming playing a role in EV components in battery parts or otherwise on EVs? Or do you see the hot stamping or warm forming coming into play?
I see one of the key things, at least in one of my previous companies that I worked for, one of the things that we always talked about with hot stamping is as you get the higher and higher strength materials and you're trying to reduce the weight out of a vehicle, you're starting to try and use thinner and thinner pieces of steel. So if you can hot stamp or hot form a piece of material so you get a thinner but incredibly stronger piece of material, that's definitely recommended. Maybe for the bottom frame of a vehicle, it might come into play, but to be quite honest, for the cells, the modules, or the packs, I don't necessarily see hot stamping really being needed or going to be driven in that direction in the future. Remember also, hot stamping, while they have had certain dramatic increases in technological advances, in that is still relatively slow as opposed to a standard stamping operation. And whether with a hot stamping line, you're going to either use a roller hearth furnace or, as they call, a pizza oven concept, that's going to take up a lot of space and energy as opposed to what a traditional stamping operation would do.
Right, okay. All right, we're at the top of the hour. I guess the last question, Stephen, you want to expand a little bit? You started to talk about price and performance ratio and strategic partnerships between metal formers and their suppliers. You want to expand maybe a little bit on why you think that's such an important thing to look at moving forward with EVs or otherwise?
Well, I think we touched on this already a little bit, but as the industry grows and obviously changes, it's going to be more important to rely on your capital equipment supplier of choice to help guide you to the different options that they can provide you for your cutting and forming needs. Again, like I said, I don't want to stand out there and tell you that SIMPAC is the only press manufacturer out there that can do this. I personally know of several other press manufacturers that are very strong and very good at doing that. And while I'd like to see all the sales come my way, I'm ignorant to think that that's going to happen. I think it's important that you need to show the feature benefits of either a mechanical or a servo press to that potential customer, and also give them an analysis of what SPM expectations they can anticipate or expect based on the technology that you're offering them. And then this way, what they can do is you can help them make a better informed decision in which direction they want to go. Remember, this also goes back to price and performance. You know, If we all had millions upon millions of dollars, yes. Would we buy the absolute latest and greatest of everything out there? Most assuredly. But in many instances, we don't have that. So the whole thing is capital equipment companies, the capital equipment company's job is not to tell you what you need to buy, but rather help and assist you in the decision-making process as to what is best for your wants and needs. We can't tell you that, but what we can do is we can help support you in that decision-making process.
Outstanding. All right. Well, we've reached the top of the hour. So again, I want to thank Stefan and SIMPAC for that informative presentation. I certainly want to thank our audience as well for attending and asking such great questions. We hope everyone found it to be a pretty valuable experience. Again, an archive of today's program will soon be available on our website within the next couple of days. We'll send you an email with a link so that you can take another look, share it with your coworkers, et cetera, within your organization. So again, thanks to everybody involved. Thanks again to Stefan. You can all close your browsers now and have a great afternoon. Thank you.